All right. So the algebra one, basically the focus is really on the rules algebra. Okay. Um, let's see if you can remember it. So they are basically we're talking about two sets of rules. One such rule is on the operator. We know it's plus, basically it's add and multiply. And another set rule is about equation. So let's look at first set. So we have plus and add and multiply. So we know that A plus B equals to B plus A. So do you remember what's that called? Hello, Abby?
Yeah.
Do you remember what's that called, this property?
Uh, I think it's associative.
No, it's not associative. It's called commutative. Good.
Can you repeat that? Your voice is cracking.
Oh, hello.
Yeah, I can hear you now.
Okay. Called commutative.
Oh,
So A times B and also B times C. That means the order, as far as the operators are concerned, the order really doesn't matter. And this is first one. And then we also have this A plus B plus C is the same as A plus B plus C. Remember what's this called?
that's commutative. I mean, associative.
Yeah, that's associative. Basically saying when we have the add something, really doesn't matter which two we start with. And that's the same thing for multiplication. Okay. And then we got this A plus uh 0 equal to A and A times 1 equal to A. And do you remember what this property is?
It starts in I.
Right. So the property is called identity. This means
Yeah.
it does not change its value. Identity. Then we have this A plus negative A equal to 0 and A times its reciprocal is equal to 1. And this one,
It's inverse.
yep, very good, inverse. And the noster will be distributive property. And AB plus AC. And because there's a commutative property, so really doesn't matter where uh which side this are. So this one got AC plus BC. Good.
Yeah.
Yeah, this is called distributive. Yeah. So this is this set of um properties for the operators. Okay, so in algebra, really focus on add and multiplication. And the reason for that is subtraction can be, say, 3 minus 5 can be look at 3 plus negative 5. Because when we're dealing with algebra, we actually, the number we're dealing with, we have positive and negative numbers. Yeah, which is a big thing, uh, especially uh, in the past, when you study like elementary school math, which is only dealing with positive number, not dealing with negative. Negative is really just the when we got to the algebra. Hello?
Yeah. I'm
Okay.
here.
All right. Now let's make sure no, why it didn't work? Hang on 1 second. Right. Okay. Hopefully that works now. Huh? Why is that? Okay. All right. Does that work here? Oh. Yeah, all of a sudden. All right. Let me try it. Something else. Um, okay. Let's try this. All right. Okay. So there's problem with the whiteboard. Okay, so we have that the set rules for operators, and then we'll have the set properties for equation, and there's another set for inequalities. Okay, for the equation, we have this. If A equal to B, then A plus C equals to B plus C. And for the inequality, we have this. If A is greater than, or could be less than or greater than, then this property holds. Good.
Yeah,
Do you remember what's this property called?
I don't remember it.
This is called addition property of equality. Good.
Oh, yeah,
Yeah.
I remember.
Yep. So learning algebra basically is learning those rules. Okay. So we need to know what they called. And also if A is equal to B, then A times C equals to B times C. And same thing here. Now there's an inequality have two situations. One is if C is greater than 0. So if C greater than 0, then this still holds. That's C greater than 0. But if C is less than 0, then we have to flip it. Good. Yeah. Okay. Hi, Matthew. Hello, Matthew.
Hello.
Okay. Yeah. Do you have any question for the homework?
No, I wasn't able to do it because we've been gone this entire week so far. So,
Okay. Make sure you get done this week. Okay.
yep, will do. Sorry about it.
Yeah. Yeah. We're doing review now. We just went over the properties for operators. We're talking about plus minus. Now we're doing the property for equations and inequalities. So the top one here is called addition property. That means when you have an equation, then you can add anything as long as the same amount on both sides. And the second, this is also true for inequality. And the second property is called multiplication property. That means if we have an equation, then we can as long as we multiply the same thing on both sides of the equation is still true. And for inequality, it depends on what C is. If C is positive, then when you multiply the same thing on both sides, nothing changes. But if C is negative, then we have to flip the inequality. So this is called the multiplication property. And we are learning on algebra 1, really what we're trying to learn here is the properties of algebra. So later on, we can, and we practice with the things we learn, like the linear equations, quadratic equations, rational equations, radical equations. Those all can help us to master the properties. So it's just kind of like when you play any sports, you had want to make sure your fundamental the skills that are solid, then you'll be able to play a good game. And playing games really just help you to getting better at mastering those skills. Okay, good. Yeah, if you're good, just give me a thumbs up. Thank you, Eddie. All right, thank you, Matthew. So now we're going to looking at clean this up. Linear equations. So when we're doing linear equations is something like this. Say 3x plus 5 equal to 9, or it could be as simple as 2x equal to 4. As long as you have a variable here, which is just x itself, it's not x squared. When you have x squared, that's called quadratic equation. So for the linear equation, we just have the variable at the first power or sometime or first order. So now to solve linear equations, you can see how the properties get applied. So the first thing we're going to do, we minus 5 on both sides. Now this is something we learned is if A is equal to B, then A plus C equals to B plus C. Well, you could ask, this is add, this is minus. How could this apply? Well, remember, minus 5 is the same as add negative 5. And when we learn the algebra, we're dealing with both positive and negative numbers. So that's why it came from this rule. Okay, but the reason we know we can do that, but we know that we can do any number. It's not just 5. It could be 100. It could be 10,000. But the reason we do that is we want to isolate the variable x. So to do that, we had to move this over to the other side. We have to move 3 over to the other side. Now the way to move 5 to the other side is by minus itself. So therefore 5 minus 5 is 0, which is, we have this rule there. The code is A plus negative A equal to 0. It's called the reverse, the inverse property. So therefore we got 3x plus 0 on this side. On the other side will be 4. That's just simple arithmetics. And we know that 3x plus 0 is just 3x because one of the rule is this. That means this is called identity property. Okay, so we got 3x equal to 4. And then we're going to multiply 1/3 of that. So this came from the multiplication property. If A equal to B, then A times C is B times C. But we time 1/3. The reason we time 1/3 is that way we can cancel 3. And that we are using this property, number times its reciprocal is 1. So we actually got, that's why we call the canceling. So basically 1/3 times 3 just 1. And on that side is 4 over 3, but also 1x is just x itself. So we know that there's 1, a number times 1 is a number itself. That is also the identity property. So we got our answer. full third. You can see that how the properties get used in order to find the answer. And those properties, we're going to use them over and over, solve different kind algebraic problems. Okay, are we good here? So make sure how the property get used. But of course, when we actually solving problems, we sometimes not writing it out. It doesn't mean we didn't skip. It becomes so trivial that we don't have to write it out. Just like when you tell people about something, sometimes you don't say certain details because everybody knows about it. So yeah, like say if you someone wants to find the bathroom, you are not going to tell them how to open the door and close the door, things like that, because that just everybody understand that. What you need to do is just tell them, you go straight ahead and turn left to right. Okay, so same thing with here. When we actually work out the problems, we just do this. We keep the important information. The sum is too trivial. We don't have to write that. For example, 3x plus 5 equal to 9. Well, we just do -5 on both sides, and then we just write 3x. We didn't write this step, even though this step is what actually happened. We just write like that. Then, so it can combining the steps. So this is just 4. Then we say we divide by 3 on both sides, which basically is times 1/3. And then we just get x. X is 4/3. And you can see that this side is normally how we express, because those things are important information. And the things that is everybody understand it, then we don't have to write it. But the problem is nowadays, if we just only show people doing this, then student may not know each step get involved. So they then it's kind of, they are not really learning how to use those properties. Okay, are we good? Okay, now let's just do a couple. Okay, let's see what you got. Eddie. Very good. So we're just -4 on both sides. Then we got 7x equal to 5. Then we divide by 7. So that's become pretty. Then x is 5/7. Okay. And sometimes it could be a little bit more complicated, but still we just use the rules. For example, we got 3, 2x plus say 1 plus 7 equals to 2. And let's see, we got 4x minus 3. So we use distributive property. The reason we do that is because we have to isolate x. So we have to separate them out. And then we got 6x plus 3 plus 7, and this side will be, this get distributed, become 8x minus 6. And this side 6x plus 10, this is 8x minus 7. And then I don't like to dealing with negative numbers, so I'm going to flip this. Because this equation, A equal to B, that means B is equal to A. This is called symmetrical property. So we got 8x minus 6 equal to 6x plus 10, then minus 6x on both sides. And we got, you can see that this is called addition property. And we got 2x minus 6 equal 10. Then we add 6 on both sides. So we got 2x equal to 16. Then we divide 2 on both sides. So x is 8. That's how we find it. Good. Yeah, again, this is just the reason they want us to do those kind of problems is help us to master the properties. Yeah, just the kind of play any sports. You practice, so you make sure you that become, you know, kind of muscle memory. It's kind of just help you, really help you to know, to get all the basics, that the skills that you need to play a good game. Okay, have you do one here. 2 7x plus 3 minus 5 equals to 3 2x minus 7, and see what you got here. Job, Addie. Okay, let's see how we do this one. Yeah, Matthew, tell me where it is kind of different from what you're doing. Good. Yeah. So we dispute that. We got 14x plus 6 minus 5 on this side is 6x minus 21. Yeah. Are you good here, Matthew, for this one?
Yep.
Then we minus 6x on both sides. And of course, this gives us 8x. And 6 minus 5 is 1. This side is negative 21. Then we minus 1. Then 8x is negative 22. Then we divide by 8. So we got x is negative 22 over 8. Then we can simplify that. It become 11 over 4. Good.
Yep. When I flipped the problem around, I left, or I didn't. The 14 became a 4 and not a 14. So I somehow lost the 1.
Okay. All right. And how about this minus 6x on both sides? Are you okay?
I subtracted 4 from
Okay.
both sides, but that's because it was a 14.
Okay. All right.
But you left it the same way. You didn't flip it around in this time.
Well, because I don't have to dealing with negative numbers because 14x minus 6x is 8x. So I didn't flip.
Oh, okay.
Yeah.
And that would have made more sense if I'd actually had 14 instead of 4.
Right.
Okay.
Yep. Okay. All right. So we have that. This is called the linear equations. And then we got into something called systems of linear equations, which we have actually two variables. Actually, there are two unknowns. So we write them as this. So let's say x plus y equals to 5, then 2x plus y equals to, say, 9. So how do we solve that? And again, you can see that we use still the same properties, but our strategy is, in this case, is we got two unknowns. So to solve that, and we know how to solve linear equations. So somehow we're going to change that into linear equations. So in this case, it means that we are going to get rid of one variable. And there's two ways to do that. One way is called elimination. The other way is called substitution. Now, elimination is pretty straightforward. We just get rid of one variable. The way we're doing that, we're going to use this equation minus that. But why can we do that? Why can we use this equation, this is 2, minus the first equation? Is because, again, that's the addition property. Okay, because this side and this side are same. Let's give an equal sign. So therefore, we can subtract them on both sides. Now, if I use this to minus 2 to minus 1, then what we got on the left is y and y cancel. Y minus y is 0. And 2x minus x is just x. Then on this side, 9 minus 5 is 4. And then we can either plug into the top or plug in bottom to find y. Now, if we plug in the top, then we got become 4 plus y equal to 5. Well, that's just linear equation. So minus 4 on both sides. Then we got y equal to 1. So this is called elimination. Okay. Yep. Are we good on this one?
What is the y supposed to equal? Just whatever it comes out to be, or should it equal 0?
Y? No, we have to decide we have to figure out what y is equal to.
Oh, okay. So it could vary. It doesn't have to come out to a.
Well, it depends on the problem.
Yeah.
Yeah. So
Okay.
this is called system equations. So that means on the top one, the x on the top is the same as x on the bottom. The y on the top is the same as the y on the bottom. So that's why we can cancel. Good.
Yep.
Yeah, we cancel that, then we figure out x. Once we figure out x, we just plug it into the equation to find out y. Okay.
Yep.
All right. Now, of course, sometimes it won't be this. It won't be that straightforward. So we had to figure out some way to do it. For example, what happens if we got this instead? Well, what we're going to do, let's say this is 12. Yeah, since we cannot cancel them right away, so what we're going to do is multiply 2 on both sides. Now, the reason we can do that, you can see that the strategy can be different, but the property is the same. Okay, just like you're playing a sports, you don't play always the same, same sequence or not playing same way, but the basic skills are there, and also the rules are there. You have to follow that. So in this case now, we're still trying to get rid of a variable. We can decide which one to get rid of. It's really up to us. We can get rid of a y. If that's the case, I'm going to multiply 2 on the first equation. So I become 2x plus 2y and equals to 10. And again, the reason we can do that is the multiplication property of equality. If x could be, then a times c is b times c. But now you can see we can use the subtraction again with this minus this. And this equation, we came from this equation. So they are so-called equivalent. Okay, top minus bottom, 3x minus 2x is x. 2y got canceled. Then we got 12 minus 10, got 2. Then we plug in, if we plug in on the top one, we got 2 plus y equal to 5. So therefore, y has to be 3. Good? Yeah. Thank you, Eddie. Okay. Now I'm going to show you another way of doing it. So this is when you're doing math, you can have different way of doing it as long as you follow the rules. You can do whatever you want. Sometimes maybe the way we're using it is a little bit harder. Sometimes is maybe it's easier. So it just really depends on how we're doing it. So if we want to get rid of x, that means instead of multiply 2, I'm going to multiply 3 on the top. So what we got here will be 3x plus 3y equal to 15. So therefore, I'm going to use this equation to minus that equation. That way you can see x got canceled. Then 3y minus 2y got y. 15 got 12, got 3. Then we plug into this equation because it's simple. Then we got x plus 3 equals to 5 minus 3. That's a linear equation. Then x is equal to 2. Good? Thank you, Eddie.
So can you explain to me again what you multiplied to the top?
Well, the reason well, first of all, I can do it, right?
You can do what?
I can multiply 3 on both sides of the equation, right?
Oh, okay, that's what you multiplied to the top?
Yeah.
Oh, okay, that's what I was wanting to know.
Okay.
Yep.
That's just the multiplication property of equality. We use that property. But the reason I times 3 is because I want to get rid of x.
Yep.
Yeah. So I'm just doing this, show you 2 different ways of doing it. Okay.
Yep.
All right. So I give you a couple to try it. X plus y equals to say 4, then 2x plus 3y equals 10, and see what you got. Good job, Eddie. Okay, if you find both x and y, so two variables. Yeah. Hello, Matthew.
Yep, I'm finding it right now.
Okay. Okay, what's x?
A negative.
Well, you got negative x equal to -2. What's x then?
I don't know.
Well, x has to be 2, right?
Oh, okay. So you divide the negative by the negative, which equals a positive.
Mm-hmm.
Oh, okay.
So basically divide by -1 on both sides, right?
Yep.
Yeah, or you times -1 on both sides. It really doesn't matter. But this side become x, that become 2. Yeah.
Yep.
Or you can think of if x is 2, what is -x? That has been -2, right?
Yep.
Okay, very good. Uh, let's try another one. Um, so 2x plus y equals to 10. Then we got 3x plus let me change that to 2y equals 15. And so I'll check out.
And we're solving for both variables.
Yep. Yeah.
Okay.
When we have this is called system equations. We got two variables, or we should say two unknowns. So we had to find them. Good job, Abby. Okay, so let's see how we do this one. Again, for this one, it's easy to get rid of y because we just multiply 2 on the top. So if we do that, then we got 4x plus 2y equal to 20. Then we can use this equation. It says 3. This equation, equation 3 minus equation 2. Then 4x minus 3x is x. Y got canceled. And this side, we should get 5. Good, Matthew?
Yep.
How come you got -5?
Oh, I think I got my signs backwards.
Okay. So once we got x equal to 5, then we either plug into here or there. Of course, we're going to pick something easier. So 2 times 5 is 10. 10 plus y is 10, which means minus 10 on both sides. Then y has to be 0 because 10 plus 0 is 10. So that's our answer. X is 5 and y equals 0. Good?
So you take your first answer and then plug it into one of the others?
Yep. To
You
5.
don't? Okay. Yep, that makes sense.
Okay. All right. So now we're going to look at a different way of doing it. It's called substitution. For example, this is simple one, a 10. Okay, so what we're going to do, we're going to replace one variable with another. So for example, we pick the first one. And again, is just like we're trying to eliminate, we'll also have to figure out which one we're going to substitute. Because once you substitute, then that means just kind of like the same as elimination. So that 2 variable problem become 1 variable problem. So that's key here. We're going to change this 2 variable problem into 1 variable problem. And since we know how to do that, solve 1 variable problem, and that's how we're solving it. So this doing math also teaches us how to actually solve problems in the real life. The real life is always, we break them into simpler ones, then we solve the simpler problems. Okay, so let's say we want to substitute y. Then we can use this equation here. Then we know that y we can write as 4 minus x, right? So what we did is minus x on both sides, which we know we can do it because I did addition property. You can see that even though we doing something different, the property is still the same. Okay, now we're going to substitute back to the second equation because this come from the first equation. So we cannot go substitute back to it. Then I just kind of circular reasoning. It won't solve the problem. So we're going to substitute the second one. And now we got 2x plus y. Y is what? 4 minus x. And that equals to 10. Then 2x minus x give us x. Then we got x plus 4 equal 10. The minus 4 on both sides, then x is 6. And once we find that, then we just go back. We're going back to the easier one. So that means 6 plus y equal to 4 minus 6 on both sides. Then y is equal to -2. Yeah, we good?
So once you got x equals 6, which one did you plug it back into?
Doesn't matter which one. So, but I'm going to plug back into something simpler because this one definitely is simpler than the second one, right?
Okay, so you plugged it back into the first one.
Yeah. It really doesn't
Okay.
matter which one you plug in, but in this case, I want to do something simpler, so I plug in the top one. Good. You can also
Yep.
plug in the second one. It's like second one, then just a little, not as simple as the top one. Good.
Yep, but why when you plugged it back in, why did x become 6, but y didn't?
What do you mean?
Well, you plugged it in and then you have 6 plus y equals 4.
Right.
But wouldn't it be 6 plus 6
No.
y equals 4?
Why 6 plus 6?
Because didn't you multiply it into both of them? Or is x just going into x?
But yeah, x, that means now we know what's the value for x, right?
Oh, okay.
So we just plug it back here, replace that with 6, right?
Okay, yeah. So you
That's the
didn't
value.
replace y as well.
No, we don't know what y yet. We're
Oh,
trying to
okay.
find y. Okay?
Yep.
Because now once we back in, we got this linear equation, right? Good.
Yep.
That's how we figure out what y is. All right, let's practice on one. Make something simple. X plus y equals to 5. Then we got x plus 3y equals to 10, and see what you got. Good job, Addie. Yeah, I'll be right back. All right, let's see. Matthew, you still have trouble doing this. Let's understand uh, where it went wrong. Okay, so again, we have to decide what to replace, what to substitute. So in this case, we can see that we can replace x with y. So therefore, we rewrite this as x equal. The reason I want to replace x because this is x. I don't have to multiply something or divide by something. Just straight for substitution. So based on the first equation, we got 5 x is 5 minus y. Then we plug in that to the second equation. We got 5. So we replace that.
How did you get x minus 5y?
Well, from the first one, we minus
What?
both sides.
Oh, you subtracted y from both sides?
Right.
Okay, well, I subtracted x from both sides.
Well, that's fine. Then you are replaced with y. Good.
Yep.
Yeah, I can show you both ways of doing it. Okay, so this one we got 5 minus y. Then we got replace x with that. Well, that's the reason we do that is to replace x with y. Then that just only have one variable. So it's 5 minus y plus 3y equal 10. And then what we got here, negative y plus 3y will be 2y. So we got 5 plus 2y equal to 10, then minus 5 on both sides. Then 2y is 5. Then divide by 2, then y is that. That's first one. Once we have that, we just plug into the first equation, and that become, or we can just use the third one because we have this already. So we can also use this one. So therefore, we got x is 5 minus 5 over 2, which give us 5 over 2. So that's how we got. Good, Matthew?
Yep.
Okay, now let's see how, if you do like your way, let's see how to do that. Then that become y, then will be 5 minus x, right?
Yep.
We got x plus, then we have 3, so we replace y with this. So 5 minus x, that is 10. Then we got this got distributed. So x plus 15 minus 3x equal to 10. Then x minus 3x is minus 2x. Then we got 15 equal to 10. Then we minus 15. We got minus x, 2x equal to negative 15. Then divide by negative 2 on both sides. Then we got x will be, oh, sorry, this is a negative 5. 10 minus 15 is negative 5. So got 5 over 2. So that's what we got. Good?
Yep. So when I did that, I had x plus 5 minus x equals 10. I did not add in the 3. I just replaced the 5 or the 3 with the 5. I didn't. So, yep, I see where I went wrong.
Yeah, right. Distribute. Good.
Yep.
Yeah, that's why we practice on those problems so that we are good with how to use those rules in algebra. Okay, so we got this one. Then we already know that y is 5 minus x. Then we just plug in that. So we got 5 over 2. Good.
Yep.
All right, very good. Make sure you get finish not just last week's homework, but also any homeworks you're missing. Okay.
Yep.
All right. Bye.
Yep. Bye.
Thank you. Bye.